Hello everyone, this is Group 8 500 Internal Server Arrow. So today we're going to present the Assignment 1 Conceptual Architecture. And today's presentation is presented by Eleanor Haoxi Yang and Nathan Qiu-Xin Cai. This is the construction of our team. Our team leader is Wan Ting Huang, and there are 2 presenters and 3 group members. So today's presentation content will include 8 parts. The first one is introduction. The second one is the evolution of the GNU step. And next is the architecture style we discussed. And the system component and interaction. Then is the explanation of use case and the sequence diagram and the concurrency consideration and division of responsibility. And the last one is the lesson learned through this project. So let's make an introduction for the GNU step first. GNU step is an open source framework that follows the OpenStep specification and is designed to provide a Mac OS-like development experience on other platforms. It was originally found in 1993. The reason for the GNU step was created is that lots of the developers need a cross-platform framework that let them to write code once and run it anywhere. So GNU step is built on the design principle of next step and OpenStep. It ensures that the compatibility with Apple's Coca API while supporting Linux and Windows. By allowing developers to write once and deploy anywhere, GNU step helps efficiency, maintainability, and platform independency. Because it is an open source project, which means that developers from around the world contribute to improving and maintaining it. This encourages community contributions and making it an involving and collaborative project. Over time, GNU step has gone through many improvements to keep up with modern software development needs. One of the biggest upgrades was multi-threading and asynchronous processing, which made application faster and more efficient. The lib's core-based library was also improved to enhance cross-platform compatibility, making sure GNU step application runs smoothly on Linux, Windows, or Mac OS. And a key milestone in its evolution was the creation of GORM, which is a visual GUI design tool that allows developers to build interface using drag and drop, just like Apple's interface builder. So this made GUI development much easier and more intuitive. And GNU step has always focused on compatibility with Coca, which means it can still run applications originally designed for Mac OS. This has helped attract more developers from the Apple ecosystem while still maintaining its open source flexibility. Nowadays, GNU step continues to evolve, especially on GitHub. GitHub keeps the project up to date, fixing bugs, adding new features, and ensuring the framework stays relevant. So let's talk about the architecture style of the GNU step. GNU step is built using the layered architecture, which means different parts of the system are organized into separate layers, each handling a specific role. At the foundation, we have libspace, which takes care of core system functionality like file management, networking, and data structure. And then for the application layer is the libs GUI, which manages graphical user interface like buttons, windows, and event handling. However, libs GUI doesn't directly render graphics, so it passes render tasks to libspec, which interacts with different platform-specific graphic systems like X11, Windows, and Mac OS. This separation ensures the system's portability. And the developers don't have to rewrite code for different operation systems. Also, GU and STEP follows an object-oriented design. This means everything is built using objects that contain both data and behavior. It also follows encapsulation, inheritance, and polymorphism. For example, in Lib's GUI, GU elements like buttons and windows inherit functionalities from base classes and reduce duplication code and make development more efficient. GNU Step has 5 large architectural components, and each one has a specific role. 3 of them we mentioned in the architecture style, which is LibSpace, Lib's GUI, and LibSpec. Now, let's look at the Lib's core base and GORM more specifically. Lib's core base provides an interface for Objective-C program to interact with the system services in order to promote performance and portability across platform. And for the GORM, it is a graphical GUI design application. And the layouts created in GORM are sorted as interface file, which Lib's GUI interprets dynamically at runtime to build application windows and controls. The interaction between these elements follows the architecture styles. Lib's GUI depends on LibSpace for core functionalities and offloads rendering text to LibSpec, while Lib's core base helps optimize system-level interactions to ensure smooth cross-platform performance. This separation of UI logic and the rendering is one of the greatest advantages of the GNU Step architecture. It makes it possible for developers not to have to rewrite the code for new platform. And GORM also offers easy and efficient UI design, which reduce the development time.
So onto the use case and sequence diagrams of GNU Step. In the first use case we have here, a user would like to set a title of a box component. They set the request to JORM app, which then sends a request to the JORM box attribute inspector component, which then uses a lower level component, the NSBox class, to then update the interface with the new title of the box displayed to the user. In the next example, we have a user who wants to add a shortcut to a menu item. So there we send a request to the JORM app, which then sends a request to the component responsible for this. In this case, it's a JORM menu item attribute inspector component, which then sends a request to the NS menu item component, which then updates and renders the new interface to the user. For the use case, this use case diagram demonstrates the 5 most common use cases for JORM. We have drag and drop, visual object configuration, interactive object connection, real-time interface testing, and project persistence and extensibility. All these interact directly or indirectly with GNU Step, which allows it to configure, load and store, serialize and deserialize in real time, which is what makes JORM a really powerful tool to make cross-platform GUI applications. As for concurrency in GNU Step, there is the NSThread class, which supports multi-threading. However, with multi-threading, there is a problem with race conditions where the threads manipulate the data at the same time. And to prevent that, we can use a mutex lock provided by the NS lock or the NS recursive lock component. And for division responsibility, one stakeholder we have is the documentation and community contributors. These people play a critical role in the community by writing and updating documentation, as well as answering questions from the user. The next stakeholder is the core library developer. They are responsible to maintain and update the core libraries of GNU Step, such as libsbase, libs core base, and libs GUI. These include low-level APIs and libs core base supporting GNU Step's higher-level frameworks. They ensure compatibility with updating standards. They optimize libraries and performance and memory usage, and they also fix security vulnerabilities. And the other stakeholder we have are the GUI and tooling devs. They're responsible for creating the GUI and development of GNU Step applications. They're responsible to develop and maintain the UI frameworks of GNU Step, and they utilize their UI design and Objective-C skills when developing for GNU Step ecosystem tools like JORM, GNU Step, ORM, etc. In conclusion, we have learned about the power of GNU Step, its history, how it has evolved, and how it uses a layered and object-oriented architecture to develop cross-platform GUI with its rich libraries, components, and the role each stakeholder plays in its development. Here are some of the sources we've used, and the end. Thank you.